In this video, we're going to learn how to apply the Pythagorean theorem in two different ways. One is we'll use it to determine if a triangle is a right triangle, and then second, we will find the distance between 2 points. So to determine if a triangle is a right triangle, we use what's called the converse of the Pythagorean theorem, which says that if that equation a squared plus b squared equals c squared is true, then the triangle has to be a right triangle. So the Pythagorean theorem itself is the opposite of that. For a right triangle, then a squared plus b squared equals c squared is true. And this is just the opposite, called the converse of that. So we might use this to say, if I gave you 3 side lengths, so if a was 9, b was 8, and c was 11, I might ask you if it was a right triangle. Notice that c is always going to be the longest side. So just to note that, because sometimes if we're not paying attention to that, we make mistakes. So determining if that's a right triangle or not, we use those numbers to test the Pythagorean theorem. So we take the 2 shorter sides and square them, and we're questioning whether that's going to equal the longer side, the hypotenuse squared. So I do the calculations. I get 81 plus 64 is 145, and that does not equal 11 squared. So because those do not equal, then it is not a right triangle. So that's a pretty straightforward concept, and I'll have you practice that a little bit tonight on your practice assignment. Next, the application of the Pythagorean theorem that really is used a lot and that you'll see a lot, is the distance formula. So at the very end of this, we're going to actually have a formula that is the distance formula. And I will tell you that I really don't use it in that formula because it requires me to memorize it. And anytime I can not memorize something, but just use something that I already know to kind of redevelop it in my mind, if I can use the concept instead of something that I've memorized, I'm always going to be better off. So I'll show you the formula by the end, but I really want you to understand it more than memorize it. So to look at the distance formula, I'm actually going to use the snowball problem again that was on your homework last night. Some of you watched the video number 1 and saw this done already. I'm going to approach it from a little bit of a different standpoint. Just in terms of how I talk through it, but it's the same problem. So I'm throwing snowballs with a friend. I'm 20 feet, so this is my house right here. I'm 20 feet north and then 15 feet east. My friend from my house is 25 feet east and then 10 feet north. So if I put our locations on a coordinate grid, I want to find the distance between them. So I want to find how far this is. So in order to do that, I can always make a right triangle that's going to help me to find that distance. So my right triangle would be, to draw my right triangle, I'm going to start with where I am and go straight down and then go over to where my friend is. So that kind of looks like a right triangle. So here's keeping in mind that I can only use the Pythagorean theorem and thus the distance formula when I have a right triangle. So I know that this was 15 feet and this was 25, so I know that this side is 10, and I know that this side was also 10. So as soon as I know those 2 sides, then I can use the Pythagorean theorem to find that hypotenuse. So I've got 10 squared, which is 100, plus 10 squared, which is 100, equals c squared. So I know that c is going to be the square root of 200. And if I use my calculator to find the square root of 200, it's 14.1. So the distance between me and my friend, or my friend and me, my friend and I think it's me, my friend and me, is 14.1 feet apart. So far you might say, well, we just used the Pythagorean theorem. How is that the distance formula? But if I do a little bit of rearranging of the distance of the Pythagorean theorem, then I can find the distance formula. So let's start with saying I found that c was my distance, so I'm going to call that the distance, and I know that the distance squared is going to equal a squared plus b squared. I know that a squared is the difference in my coordinates on the x-axis, and b squared is the difference in my coordinates on the y-axis, or vice versa. It doesn't matter. So the difference in my coordinates is going to be x1 minus x2. So in the case of this problem, I took the 25 feet that my friend was east of the house, and I subtracted the 15 feet that I was east of the house to get the 10. So that's the difference in my x's. And then I also have the difference in my y's, which I'm going to call b here. So that's going to be y1 minus y2, and that's squared. And again, that's going to equal my distance squared. And I don't really want my formula to be the distance squared, so I'm going to take the square root of everything. So I bet d for distance is going to equal the square root of the difference in my x's plus the difference in my y's. So this is the distance formula. You can see that it's just a rearrangement of the Pythagorean theorem. So I really just use the Pythagorean theorem, and I rearrange it once I've plugged numbers in and I'm working with it. I don't ever actually write this down. You might want to try working with this, but if you really understand where it comes from, that this is your A and this is your B, and then you're taking the square root of that to find that diagonal line, which in our little map is the distance between those 2 points. So now I'm going to give you 3 problems to practice, and then we'll be done with this video. The first 2 problems, you're going to determine if a triangle is a right triangle, and the third problem, problem C, I'd like you to find the distance between those 2 points. When you've done that work, you can unpause the video and check your work. So as you check your work on these 3 practice problems, I just want to point out a couple of quick things. Notice that when I set up my a squared plus b squared equals c squared, that my longest side is always the c. So you've got to make sure that these 2 sides are shorter than that one. So in A, those did equal, so it is a right triangle. In B, they didn't equal, so it's not a right triangle. On part C, when I'm looking at the distance formula, I'm looking for the distance between -3 and 2, which are the numbers on the x-axis. I'm looking for the difference between 5 and -1, which are the numbers on the y-axis. I'm squaring each of those and then taking the square root of everything. So I've got the distance is the square root of 61, or simplified to 7.81 units. So that's it for today.